These are notes for Chapter 3, Graphing Linear Equations Using a Table. And once we start Chapter 3, we introduce two variables instead of one. Chapter 1 is dealing mostly with x. And now in Chapter 3, Chapter 1 and 2, I should say, Chapter 3 is dealing with both an x and a y. As you can see in the equations, number 1 and number 2, there's two different variables, an x and a y. So in order to graph a line, because that's what these pictures are going to make, a line, we need to first solve for y, meaning get y by itself. And you can see on number 1, it says y equals already. Same thing on number 2, it says y equals. So we don't actually have to solve for y, it's already there. Secondly, we need to make a table by doing some substitution, some pre-algebra work, plugging in numbers for x and seeing what we get for y. Now, the numbers that you pick for x, you could pick anything. You could pick 100, you could pick a half, you could pick negative 32, but we would like to pick smart numbers that we're able to see in our coordinate plane, in our graph. And so if it goes from negative 6 to positive 6, I would like to pick numbers around 0, so negative 2 to positive 2. Same thing on number 2 over here, negative 2 to positive 2. And the rest of it is a pre-algebra substitution problem. We basically have 5 different problems. If our equation is y equal 2x minus 1, well, I'm going to find out what y is equal to when I substitute in a negative 2. So 2 parentheses, negative 2 minus 1. All of these values for x, I'm plugging in for x. So I have to do this 5 times over. 2 times negative 1 minus 1, 2 times 0 minus 1, 2 times 1 minus 1, 2 times 2 minus 1. And all of these, of course, are y equals, y equals, y equals, y equals. 2 times negative 2, negative 4. Negative 4 minus 1 is negative 5. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. 2 times 0 is 0. 0 minus 1 is negative 1. 2 times 1 is 2 minus 1 is 1. 2 times 2 is 4. Minus 1 is 3. Again, this goes back to some gateway pre-algebra, beginning of the semester number skills that students need to have. Once we have this table, what we have are 5 different ordered pairs, x comma y, negative 2 comma negative 5, negative 1 comma negative 3, 0 comma negative 1, 1 comma 1, and 2 comma 3. Once we have all of those points graphed, we connect the dots and we get our line. These are the solutions for our 2 variable equation. Same thing on number 2, I got to take all of these values and plug them in for x. So that would be negative 2 plus 4, negative 1 plus 4, negative 0 plus 4, negative 1 plus 4, negative 2 plus 4. Taking these values for x, plugging them in for y. At the top, you would get 6, and then 5, and then 4, and then 3, and then 2. So again, if I go graph these, x first and then y, x comma y, negative 2 comma 6, negative 1 comma 5, 0 comma 4, 1 comma 3, 2 comma 2. Connect the dots. There's our line. Now, when we have a fraction, like we do on number 3, we can't just simply go through and pick negative 2 to positive 2. If we pick negative 2 to positive 2, we're going to end up with some more fractions in our graph, which is going to be difficult to graph the ordered pair. For example, if I were to take negative 2 and plug it in, I would get negative 2/3 minus 2. Well, that would give me negative 2 and 2/3. Well, the negative 2 part, I can come left negative 2, but down 2 and 2/3, that's kind of in between, and that's not going to make for a real clean graph. So what we want to do is pick numbers that avoid fractions in our answers. We want to pick smart numbers that make the fraction go away. And in order to do that, I simply pick numbers that are multiples of the denominator, multiples of the bottom number. So I can pick 3 and 6, and I can also pick negative 6 and negative 3. And then from there, I do the same substitution. 1/3 times -6 minus 2. To multiply fractions, we multiply the tops. 1 times -6 is -6. Multiply the bottoms. 3 times 1 is 3 minus 2. -6 divided by 3 is -2. -2 minus 2 is -4. So you can see the fraction went away. And yes, there's a little bit more work with these fractions, but it's the same process of plugging in a number. So if I did -3 now, that's 1/3 times -3 minus 2. 1 times -3 is -3. 3 times 1 is 3 minus 2. -3 divided by 3 is -1. Oops. -1 minus 2 is -3. Take 0 and plug it in. Anything times 0 is 0. And 0 minus 2 would give me -2. Now, the nice thing about linear equations is that there should be a pattern happening in the y values. You can see it up here in our first two examples. It's going down or up by 2, up by 2, up by 2, up by 2. And over here on number 2, it's going down 1, down 1, down 1, down 1. 6, 5, 4, 3, 2. The next one would be 1. So we can use that so we don't have to plug in so many numbers. If we can see the pattern, -4, -3, -2, -1, 0. Then I can graph these ordered pairs, -6, -4, -3, -3, 0, -2, 3, -1, and 6, 0. Connect the dots, the points, and there's my line. Now you'll notice on number 4, it's not solve for y. It doesn't say y equals. Remember, that's our first step to graph using a table is to solve for y. Well, number 1 is already solved. Number 2 is already solved. Number 3 is already solved. Number 4 is not, which means I need to get y by itself. So the first thing I would do is subtract 6x. So that says 3y equal -6x plus 3. And to get rid of a times 3, I can divide by 3. Y equals -2x, 6 divided by 3, plus 1. Now, this is the equation I'm going to be using to plug in my values. I can plug in -2 to +2. And now I have some basic arithmetic. -2 times -2 plus 1. That would give me 5. And then I have -2 times -1 will give me 2 plus 1 is 3. Then 1, then -1, then -3. And again, I can graph this ordered pair, -1, 3, 0, 1, 1, -1, 2, -3. And once I connect the points, I get my line and the solutions for the two variable equations. Hopefully that was helpful, and thanks.